Hello everyone. Welcome to another Pulu Sound stream. It's been a while since the last one, which is because I was in Japan for 3 weeks, and after that I was sick for a while. Yeah, feeling a bit better now, still coughing a bit and, you know, having a runny nose, but at least I'm not feverish anymore. I returned to work this week and I'm slowly getting used to, like, normal working days again. Yeah, I have kind of a creative coding goal in mind that you might be able to guess from the title of this stream, but I guess other than that I wanted to talk a bit about the trip because it was a lot of fun. I went with some friends to Osaka, then we traveled through Kyoto, through Nagoya, Ito, Tokyo and Sapporo, and finally back to Osaka and then home, which is kind of an intense trip for 3 weeks, but it was a lot of fun, and fortunately I only got sick during the last days, so yeah, didn't miss much due to that. One of the things I did in Japan was shopping for, well, all kinds of things, but okay, well, for example, I got this very cute Jigglypuff plushie. Just a second. Yeah, and some Kirby stuff. Here's a sleeping Kirby plushie. Very cute. I got Koro Koro Kirby for the Game Boy Color. This is an interesting game in that instead of pressing buttons, you control this by tilting the Game Boy, so it's got a tilt sensor built in, which makes it difficult to play on, you know, flashcards that don't have that hardware. And it's a pretty fun game. And also I just really like the look of the cartridge, you know, because it's this translucent pink, so you can see the PCB inside. Yeah, I got some light up kitties from a gotcha machine. I was trying to pull for some pink or violet ones, but I didn't get any, so instead I have all the other colors. But yeah, something I was really looking forward to and did end up enjoying was shopping for used electronics, which you can find some pretty good deals in stores like Hard Off, where they just have a junk in quotes section where there's all kinds of random electronics, and no guarantee that any of it works, but if it does, then you can get some really, really good deals. Yeah, one thing was I got this Super Famicom. This one was actually tested to work. so it was, I guess, not the cheapest it could have been, but I like to have that guarantee, because I couldn't really test that myself unless I was gonna buy also some games for it, which I didn't. Then I got a new microphone. This is a Audio-Technica 2020 AT2020 condenser mic. It's not like super high-end or anything. It's, I think, about 100 euros new, and I got it for half that, which pretty good. It works. The reason I'm not using it yet is because it didn't come with a mount attachment, and it doesn't really fit into the one I have here, so I'm still waiting for the attachment to arrive so I can start using it. And then, probably the best deal of all, which is gonna lead us to tonight's topic, was that I found a Kinect, you know, the camera accessory for, or peripheral rather, for the Xbox 360. So it's the very first Kinect. That one was completely untested. I got it for 1100 yen, which I guess is something like 7-8 euros. And I immediately had to test it when I got to my hotel room that night, and it did work. And I was so happy about that, because yeah, it's a pretty good deal. So what I would like to do tonight is try to get the Kinect working with openFrameworks, which is a C++ framework for creative coding, especially graphics stuff, like real-time graphics and such. I have some previous experience working with the Kinect, but that was using processing, and it was also on Windows. So now I'm on macOS, which is not, I guess, a natively supported platform for the Kinect, given that it's a Microsoft device and all. But there is a library called Kinect, which works on macOS and Linux, among other things, I guess. And yeah, what I did before this was just install Kinect, because Kinect comes with a few test applications that just let you try out the camera and see whether it's working. So on screen I have this Nix flake, which actually does that. So I'm getting a specific version of, or revision of Nix packages. And from there I'm just basically setting up a developer shell, which includes the Kinect package. And trying this out, given this flake is as simple as typing nix develop. When I do this, or did this the first time, it of course took a while to install all the stuff. Now it's already installed, so now we have a shell with the Kinect things installed. And yeah, now if I type Kinect dash, we can see that there's a bunch of applications for testing out the Kinect. Oh, and one thing, I would like to show you the Kinect, but I have it right now mounted right next to my webcam, and it's a bit of a hassle to take it away, so I can't show you that, but okay, maybe I can show a picture. So yeah, this is what it looks like. Can I get this any bigger? So yeah, actually here we see some stores selling a used Kinect for 40 euros. So indeed, I got it for a pretty good price. So what do we have on the Kinect? I think this little hole here is probably a microphone, but there's two cameras. One of them is like a normal RGB camera, and then the other one, I don't know which one is which, but the other one is a infrared camera. And then I think this thing here is like, if I remember correctly how this works, I'm not entirely sure. It shoots out like some maybe infrared lasers to create a pattern, and then I think maybe the IR camera reads that, and based on that you get a depth image, which is telling you how far away from the camera different parts of the image are. Well, yeah, that is what you get. I'm not sure if that's exactly how it works, but I mean, you can look it up if you're interested. It doesn't really matter right now for our creative coding purposes. So, yeah, let's try to run something. I think CPP view is one of the more useful ones for me. Okay, and first issue is that excuse me, still having a bit of a cough, as I said. Trying to mute myself beforehand, but not always succeeding. Yeah, so the first issue is that the Kinect test applications actually require X, and for that to work on Mac OS we need to run this through Xquartz instead of a regular terminal. So let's go into that folder, run nix develop again, and Kinect CPP view. Okay, now it's reading some stuff like the device tilt, and I got this kind of window, but it's all black. This just happens sometimes. It doesn't always manage to open reliably. It might actually help if I disconnect the USB and reconnect. Might have to do this a few times, it's a little bit temperamental, I guess. Okay, here we go. So this is what the CPP view application gives us. We get the depth image. So I guess things that are blue are quite far away, and then it goes through green and yellow and orange and red the closer we get. And then there's black areas where we don't really have valid data. And that's one of the slightly annoying things you run into when working with Kinect, that you can get black data when things are too far away or when things are too close, so you don't really know. So, for example, if I start to move my hand too close to the camera, we can see that it turns black in the depth view. I guess there's something like white is the closest detected. But yeah, at this distance where I'm sitting, seems to work pretty okay. Like, okay, there's dark spots here and there, but that's just how it is with this device. I mean, it's the first Kinect. I don't remember when it was released, actually. I mean, Xbox 360 is getting pretty old. Okay, released 2010, so it's a 13-year-old device. And it was like a consumer device, so probably not state-of-the-art technology-wise even back then. But you know, it's some fun data to play with. Yeah, so as we can see, this is working with Kinect, but then the next thing would be to try to get it working with openFrameworks. And just a second, I'm just realizing that I need to turn on Do Not Disturb mode, and that is done. Yeah. Where was I again? Yes, openFrameworks. openFrameworks.cc, and I actually have some version of this installed, but let's get the latest one. So we'll download, then let's see if the Xcode thing, or the Xcode guide, has any interesting stuff. I wonder if my Xcode is new enough. Ooh, I think it's not. But it might not matter. Let's try this anyway. Unpacking. Oh. Okay, I might need to try this with the Mac OS built-in extractor. I feel like the Archive browser is having some issues lately. Archive utility. Right, there we go. Still have to copy it from wherever it extracted by default. Alright, and then we should be able to make a new project with project generator. Oh, this verifying takes a long time. What? Okay, that's weird. So they want me to move this up a level, then back in here. Okay, sure. Don't know what that was about, but probably some security features. So now that we're creating a new project, we immediately have some interesting options here. The OFX Kinect add-on apparently comes with the openFrameworks distribution. So, you know, maybe I'll just add that. I think you can add more of these later. But, you know, OSC is something I usually end up using, so let's put that in as well. And now the hardest part, coming up with a project name. Any suggestions, let me know in the chat, but I'm not feeling very creative naming wise, so I'm gonna go with something very generic. Kinect 1. And we'll generate that. And there's an error. Okay, yeah, I think this is where we run into Xcode compatibility issues, probably. Or not even Xcode, but it seems like it's looking for some file system symbol which is not found. So let's try an earlier version. So I already have 0.11.0, but I guess let's get the latest patch version of the 0.11 series. Okay. And then try project generator again. I feel like this one should work because I have been using 0.11 on this machine before, so... Okay, and then we gotta do this weird thing again. There we go. Okay, let's put in OFX Kinect and OFX OSC and go with Kinect 1 as the name. Okay, that was successful. And now they recommend using Xcode for this, but I really don't like Xcode, so I'm gonna skip that and go back to Emacs. So our app is now in here. Let's open that in Emacs. And luckily we also have a make file. Let's see what we have in there. Okay, so this is mostly just referring to stuff in here. Right, so we have at least a run debug target, and I feel like there's also, yeah, run release. Okay, that should be enough to get us started. So we can just say make run debug. Or not. Okay, maybe we have to do make debug and then make run debug. Yeah. And while that's building, I guess we can open the code here. So we have the main file, which doesn't do much as it is. Sets up OpenGL with a particular resolution, and then run app with this ofapp class, which is defined in ofapp.h. And so we have a setup, update, and draw function. We have event handlers for various inputs. And then we have a corresponding CPP file where these methods are implemented, and right now, as we see, they don't do anything. I think I have flight check mode on. I don't want to set it up properly, so I'll just disable it for now. So yeah, I guess once this finishes building, I imagine it's just going to give us a window that displays nothing and does nothing. Don't remember how long this build usually takes, but because it's the first time build, so it's building a bunch of library code, and that always takes a while, but it gets a little bit faster on subsequent builds. I guess I can close exports at this point. Well, while it's building, let's actually look at OFX Kinect, because I have no idea how to use that. So the first thing we can see is that OFX Kinect is a wrapper for a Freenect Kinect device. So this should work for us because Freenect also works. I wonder if they have some examples or if it's just the API documentation. Okay, this is an older version. So here is something, but it looks kinda complicated in that there's a bunch of classes and stuff. I wonder if there's any sample projects. Oh, here, Kinect example. Alright, this looks better. So let's see. I guess we'll wanna include the header. And we'll want to have a member variable of type openFrameworks. And interestingly, this is also using OpenCV, but I wonder if that's really necessary. I guess we can just go ahead and copy all of this initialization code. This was in setup. Testing, testing. I think this is coming through again. I sure hope so. Yeah, looks like it is. Okay. And while that was happening, seems like we got a linking error. Okay. libcurl. The fix is to install Xcode 11 or newer, but I do believe I have that. Yeah, 11.3. Okay, maybe we need to do something with this. I always forget how you're supposed to run this. Is it like applications? Okay, that looks better. No, I'm not sure if I have to clean or not. Probably do, because might be a whole different version of everything. Okay, and then we'll have to I'm just gonna comment out all of this for now, so we can just try building without, you know, anything interfering. Like just build the blank application. And we wait a bunch again. Not sure if the music volume is okay, maybe I can turn it up a little. Oh wow, that seems to have compiled and quite quickly too. Okay, so we have the blank application. It's just a gray window with nothing basically. But it's a start. And then I guess we can get started with the Kinect stuff. I'm gonna add a little bit of error logging. Okay, let's see if this does something interesting. Okay, now launching, and we were able to open the connection. That's nice. Okay. Then I think the next step would be to try to get some kind of image out of it. So the way that works is, I guess we need to call Kinect.update. Check whether there is a new frame. And then we're gonna get depth pixels, but what does that actually return? Char pointer. Okay, here we can get an O of pixels. So if we use get depth pixels ref instead, then I don't remember how to render an OF pixel, so I'll have to look that up. Okay, so yeah, we need to put them into a texture, but actually we can get that directly. Reference. Okay, well then the question is, how do we draw an OF texture? Oh. There is a draw method. How intuitive. Although this is not the right place to do that. I think this code should go in draw, actually.
I'd like you to meet our very charming little drummer.
Let's see if this does something reasonable. Oh, I forgot to bring back my camera image. Okay, so draw needs at the very least some coordinates. I think we can just put 0 and 0. No. Oh, somehow I removed the... Oh, also, we're supposed to use get depth texture instead of this, sure. That's not drawing anything. It's interesting that we're supposed to use get depth texture, but according to the documentation there is nothing like that. I wonder which version this is from. Okay, hold on, I'm signing into GitHub on the other screen. Okay, and didn't even take me where I wanted. Let's go to this code. I don't know why I'm browsing this here, I could do it in Emacs as well, but whatever. Okay, so here we do have a getDepthTexture method. I'm gonna try also the other one. Also, I might need to give width and height here, but I think by default it should draw at the width and height of the texture itself. How do I get the width of the window? Okay, of get width. Like so. But also I don't really need to check for newness of the frame, right? I'll just do this on every frame. Okay, well now we get a black window instead of a gray window, which suggests that it's drawing something, and maybe I need to replug the Kinect again. Oh, would you look at that? So now we are actually getting a depth texture. That is pretty cool. Then I guess similarly, you know, I'm just gonna open the header file here. Okay, so get texture is gonna give us the RGB image. let's just try drawing that. And we get the RGB texture just fine as well. Very nice. Then, I think I would like to make a shader which takes both of these textures as inputs, and then we can have some fun with manipulating the image. Okay, I have some older projects where I use shaders, so I'm just gonna check there how that works again. Video effects should work, or actually VCAM is probably newer. We'll just call that shader. Probably don't need anything else from here. Okay, I think there's a particular structure you have to follow first for putting the shaders in. I think they go in the bin /data/. Okay, yeah. So there's a data folder. I'm just gonna put shaders and copy these. Or maybe I'll call it Kinect. So you give it just the prefix name, and then it looks for the .worth and .frag files. And I guess I was using camel case before, but I'm not gonna do that now. And this, I believe, is in setup. Yes, it is. I guess let's do this before the Kinect stuff. So shader.load, shader name. Alright. then... Now yeah, here I have some code to reload the shader, which could come in handy actually. But this is set up to use OSC, and I guess for this project it would be easier to start with keyboard input or something, but whatever. Okay, so in draw we're gonna say shader begin, and I guess we need a corresponding end. Now instead of that we're gonna do some stuff like this. So in our shader we're gonna have uniforms called RGB and depth. I guess these numbers need to be different. I guess we'll want to pass in time and resolution at the very least. These other things are not really relevant here. And we'll want to draw a rectangle. Not sure if we need this in here. Okay, that's our drawing code. Then okay, I think I put the shaders in the wrong place. Yes, I did. So the vertex shader is pretty standard, boilerplate, I guess. And then this is where we need to take our RGB and depth. Don't care about that. All sorts of math here, but this is basically what we care about right now. And okay, now the stuff that I deleted. Yeah, so we're just gonna use UVs. So it's gonna be from 0 to 1, I guess. I never remember how this sampler to direct works, but let's try that. Okay, I could actually copy. Vec 4, or rather Vec 3, color. We'll take RGB. Oh right, okay, so there is a multiplication by resolution, which means... because this is... resolution is now the viewport resolution, but what we need is the texture resolution. So we'll need to pass that in separately. And I guess there's a way to get the width of a texture. Now, where is that gonna be? Well, there we go. Get width and get height. So I imagine the RGB and depth textures are gonna have the same resolution. And so instead of resolution here, we'll need to use text resolution. And that should maybe work. So now I would again expect to see the RGB image, but this time rendered by a shader. Okay, there's an error in the shaders. Version 4.10 is not supported. Oh, maybe there was something I have to do. Yes, I remember this. In the main function we have to set the GL version, and I guess we'll just remove that thing. Still errors. Let's get rid of this so we can see better. Okay, yeah, so texture gives us a vec 4, but we're assigning it to a vec 3, so we gotta take just the RGB. Oh, well, it works, although I'm upside down. That's funny, but I guess it's just a matter of flipping the y coordinates. No, that's not gonna work. Yes, there we go. And at this point it would be nice to have a key to just reload the shader, so let's implement that. We have a key pressed event. Let's first see what kind of key codes we get. I guess I can probably just compare these two characters. 114 is R. That's probably the ASCII value. Oh, funny, this is actually the exact same the exact same thing. So like that. But now if I run this, I should be able to make changes to the shader and reload on the fly. Okay, so I can press R. Let's put this side by side. like so, and go into the shader code here. Now if I change this to depth and reload, then we can quickly switch between different things. That is nice. Okay, let's do something interesting with the combination of these two images. Also, I'm noticing there seems to be a couple of stock pixels on the Kinect. I don't know if it comes across on stream, but there's a green one here, but not a big deal for me. Okay, let's put this into a variable and then here I believe the RGB channels are all the same, so it's enough to get just R. And then we can do something fun like just multiply these two. And that gives us this interesting thing where I guess things that are further away are a little bit darker. It's kind of hard to see though. I can add a bit of a curve to this so it's more dramatic. Yeah, now we can see it working. So if I scoot back a little, I should... Well, I'm gonna run out of headphone cable, but you can see me darkening a little bit. Also, it seems like maybe there's a bit of a dead spot on the IR camera, or maybe the lens is just dirty or something. Okay. Next, I would like to use this for some feedback type of effects. In order to do that, I'm gonna need to use frame buffer objects or FBOs. I'm not sure if I'm actually gonna need two the way it's set up in this VCAM code from before. Oh, now I realized that I should put these the other way around. Okay, now everything fits nicely on screen. Oh, hello SynthDev. Welcome to this little Kinect experimentation session. I'm gonna have to check how I used the FBOs. So, okay, first they need to be allocated. That's fine. And there's one FPO here. And then I guess there was some good reason for using the other one, though I don't see why. Okay, let's try out one FPO first. Or rather, let's call this one feedback FPO. Oh, this will be in the setup. So we'll allocate it using the dimensions of the viewport. Then I guess here I'm just initializing the contents or the pixels of the FBO to be all black. Okay, and then in the draw function, whoops. We'll wrap everything in begin and end. And we'll have to pass another uniform texture. Let's call this feedback. And that'll be number 3 and feedback FBO dot whoops get texture, I believe. Yes. And that should give us the feedback, but now there is nothing being like drawn to the screen, it's all going into the FBO. So I think we can just do this. Okay, let's try it. Okay, seems to work, but now it's flipped again for some reason. Maybe it's because of the FBO somehow. I don't know, but I'm gonna undo that in the shader. reload, and we are back the right way round. Okay, and now I'm gonna put the color to just the RGB for now. Oh, and now we should be able to get the feedback. And here we want to use resolution instead of text resolution, because this is gonna have the viewport resolution. Let's try to do some feedback by mixing the current frame and the previous frame. So that's X, Y, A, RGB feedback. 0.9 should be pretty noticeable. Oh, well, assuming it works, of course, which it didn't. No matching function for... Oh, right, because this is not a vec2, it's a sampler to direct. Alright, now we can see that we have some feedback. My hand gets kind of motion blurred, or like temporally blurred. And yeah, we can even increase this to 95% to make it super drastic, or okay, let's try 99. Now I really have to stay in the same place for a long time for it to update. Also, I think we might be hitting some floating point precision issues where, you know, some areas just... I don't know how to explain it, but I think it's a floating point precision issue where some areas just like don't turn all the way back to what is coming from the camera input, but they stay a little darker, or yeah. Yeah, so that's fun and all, but in my opinion the real fun with feedback comes when you start to distort the feedback in some ways. And I'm gonna need some noise functions, or well, not really need, I guess, but so something fun to do here is we'll make a separate UV variable for the feedback. And put a bit of an offset there. And what that does is makes the image kind of flow in time in a particular direction. So now that we have positive y, it's going upwards. Let's make this negative, so it's going downwards. Kinda funny to like run down like that. And then we can play with the values to like have different speeds basically. And also we can tweak the feedback amount here still. So yeah, you get this kind of trippy effect when you start to make some movement here. And I'm a big fan of this type of stuff. Let's try Jigglypuff. Okay. Yeah, that's basically the simplest like UV distortion you can do. But we can do more than that. What about an effect where everything is kind of flowing outwards? For that, we're gonna need to do a bit of trigonometry, I guess. Okay, first of all, let's make a bipolar UV value. So now we have UVs going from 0 to 1 along X and Y, but I would like to remap that so that we have -1 to +1 on both axes, and then 0, 0 is going to be in the middle. And that's pretty easy to do. We'll multiply our UV by 2 and subtract 1, and that is basically it. Although well, that's not something we can use directly, because we'll just get weird stuff like this. Actually, I think what I want is functions to convert between unipolar and bipolar. So let's see, in the VCAM project I noticed that I had a GLSL, or a few actually, GLSL code libraries. So yeah, we have, for example, a math thing. Okay, I'm gonna copy this over. Where is this, by the way? Maybe I'll just copy the whole folder. and just use what I need. So how do I import again? Pragma include. Yep, that still works. And well, this is the place to define our unipolar to bipolar functions. Although okay, yeah, I'll just go ahead and do that. So we have a value from 0 to 1. This gives us a value from 0 to 2. We subtract 1 and we have -1 to +1. Then we'll do basically the opposite, so we'll add 1 and multiply by 1/2. Like so, and now just as a sanity check, I think if I write this, nothing should change. Well, that was not the case. What did I do wrong? Oh, there we go. Right. Then I guess I want basically the direction of the current pixel relative to the center, and that will be given by the arc tangent or like this is the angle, right? Actually, I'm not sure I need to do this. Okay, let's try. We'll take the regular UV, then we'll add UV by scaled by some pretty small number. Okay, yeah, that gives us already pretty much the thing. Okay, this is going now inwards instead of outwards like I actually wanted. But I guess to fix that we just subtract instead of add. Yeah. So now we have an outward kind of flow. And what I want to do now is try using the depth texture, because that'll give us now something where the amount of flow basically depends on the distance to the camera. It's a little bit weird. What if I do basically inversion of the depth? So now I guess things that are further away will flow more, except when they're like very close and out of the camera's valid range. Could probably do some mapping or remapping here of the distance values so that because now it's going from 0 to 1 and I don't know how far you have to go to actually get like 0. But for doing this kind of experimenting, it's not that important to get that so precise, I think. But let's try so linear to linear. First we give the depth, then the input range, and then the output range. Try something like this, and then we might need to clamp this. Or put it on a separate line, I guess. So now there should be Actually, I got this backwards. I wanted this to go like so. Okay, so now we can see that there is some point where it basically just stops doing the flow. So I think if we adjust this number, we can bring that limit closer, or threshold. Yeah, so by experimenting a little, I can get it to where it'll only affect me, almost, because I'm close enough. Although, I guess this mic stand is also gonna be close enough. But, you know. So yeah, that's something you can do with depth. Yeah, so it really is outwards, so if I put my hand up here, then it goes upwards, and yeah, like you would expect. There's stuff we can adjust, like the speed again of flow. Or, yeah, in practice it's speed, but really this is like a factor that tells us how much the feedback image gets like displaced per frame, and with large numbers we can see that okay, every frame actually moves things this much, and it gets into this kind of more glitchy effect. Which I think is pretty cool. You can try even bigger values to like really get into the glitch territory. And why not try the reverse direction again, so we're going inwards. I think this one is kind of fun. So by bringing things close enough, I can bring them into view for a moment and then have them disappear into the glitchiness. And on each feedback iteration, we can do more than just, you know, displace or distort the texture coordinates. For example, we could tweak the color. Something that's pretty drastic, I guess, would be to invert on each feedback iteration. Oh wow, that's really something. Okay, not quite what I wanted. I guess this is happening because we're mixing the feedback image into every pixel, even though it's just these where we're doing the like displacement stuff. It's actually something we can adjust. If we multiply by depth norm here, then maybe instead something like this. So now everything that is outside of the distance threshold is not getting any feedback at all. So if I go back here, you can see that my fingers are moving without any feedback. Actually, maybe remove the multiplication here and then we just have it like hard cut off and doing the same amount of displacement regardless of distance. But on the other hand, this was kind of interesting to get a bit more variation. Yeah, so what else? Okay, maybe now I'll try the inversion, because this should only now affect certain areas. Yeah, okay. We're really getting into the glitchiness here. Oh, I actually quite like this one. Let's try going outwards instead. Yeah, I think inwards is better. We can try different values. Oh, this one gives me a bit of a headache almost. Yeah, that's one color effect we can do. But yeah, it is very, very dramatic. What if instead we multiply the color by, let's say, 0.8 to darken on each iteration? Yeah, I guess we get darkened or lightened. Oh, this one's actually pretty interesting. We get a bit of a glow going on. Whoops. Yeah. Although I kind of don't like that it always everything glows or excuse me, everything grows lighter towards the viewport center. It would be cool if it did something like follow my head, but that's gonna be a bit more complicated. I don't think I can do that tonight. Might need OpenCV to detect shapes or something. However, in here I have some interesting color functions such as hue shift, and that's something we could try with the feedback. So I don't remember what the range is here. Is it like 0 through 360 or what? But okay, let's try 0.01. Okay, that already clearly does something. So yeah, this way we can get some rainbowy effects going on. And we kind of have to tweak these numbers in relation to each other. So if the flow speed is something like this, then maybe we want a bit more hue shift per feedback. I really like what this is doing to my hands. It's pretty cool. Can try outwards again. I feel like this would work better if I had a bit more lighting here in the room. It's, you know, the source image is a bit dim to begin with, so. But that's fine. I'm gonna try inverting the normalized depth. Okay, that did not work because I made a typo. This is not working as I expected. Well, that's fine. Yeah, so outwards flow is something. What else could we do? I do usually like to do something with noise. I'm gonna comment out that block and start on something new. So as a first step, we're just gonna use the RGB image. We're gonna make feedback again, but this time I want to do something else with this. So I have here noise functions. I think P noise is a good one, periodic. Although, does it have to be periodic? Maybe not. So, okay. First things first, let's just render some plain noise. So the noise function is going to give us a float. It takes a vec3, let's initialize that with 0. That did not work. Oh, I need to include this. Oh yeah, this is just gonna give zeros, or like the same value for every pixel. So if we put in UV, okay, now we can see something happening. Let's multiply to get a bit more variation. So now we can see we're getting some noise. I believe this is actually in the range -1 to 1. So I thought I would convert that, but actually these functions operate on vec2s, whereas I now want floats. So we'll add float versions. And finally, I would like this to vary with time, and we do have a time uniform, so we can get that to vary. get something like that going. That's fine, but maybe I wanna make it a little coarser still. And I wanna start combining multiple noises. Now we'll make it noise 2. Add a bit of variation and shuffle the parameters around. There's of course a lot of different ways to combine noise. But also I think I wanna have a different time scale on this one. Maybe I wanna do an uneven weighting. So let's say this one contributes 75% and the other 25%. Yeah. Let's add one more. Yeah, something like this, and then we can tweak the ratio a little bit. Then maybe yes, something like this. Okay, now that we have noise, we can start applying it to some things. For example, we could just do something like this, where the feedback amount is just gonna depend on the noise. Oh, to comment this back in. Now it doesn't seem like it's doing anything. Okay, it is, but it's just kind of hard to tell. That is fine though. Let's put this to a constant 0.9 and then I'm gonna try using the noise as a hue shift amount. Ooh, something weird happened there. Okay, yeah, we can get some weird cloudy patterns going like that. And it kind of looks like I'm infected by some moss or poisoned or something. What if instead of the color we use this to so even without any feedback we can do some fun stuff. Get these patterns going. But what I really wanted to do with this was to adjust this feedback UV. Or not necessarily even feedback UV, but let's bring this in a bit later. Although these things depended on those variables, so I'm just gonna keep them there. But so what if we make an RGB UV? And here we're gonna that did not work like I wanted because I have this backwards. Okay, yeah, this actually does what I want. So we're gonna multiply this by the noise, and that should give us some distortion. Yeah. Let's get rid of the feedback for a moment. We can make this even more dramatic. With this kind of effect even. And then we can scale this by, well, let's say the depth. Something. But maybe I do want to mess with the feedback after all. Actually, something I do not want to do is convert this to unipolar. had something in mind, but I kind of forgot what I wanted to do. But, well, this is something. Try some horizontal distortion for a change. I'm gonna try the normalized depth again. Oh wow. That did not really do what I was expecting. Oh, it's because I forgot the clamp that I used before. There we go. So yeah, now I can get this weird flowy effect that's basically just affecting me. And at this point I think I can make it a bit more dramatic too. Just trying to wave around something that has some colors. Yeah, I kind of like this one. Could of course keep going with this. Oh, let me try. Something else we could do is tweak saturation based on depth. Let's see, so do I have something for that? Okay, not really. But it's easy enough to write, so basically it's gonna be very similar to the Q shift function. Something like that. We can try just this should give us a grayscale image, I guess. Oops, the other way around. Yep. So now instead of putting it there, I'm gonna try that. Yeah, now we can see that I am pretty much the only thing in the scene with non-gray colors, with saturated colors. Now this is quite cool actually. Possibly we could even do it so that just check here for it's like a just the cutoff kind of thing, and we don't have to go all the way down to 0, of course. We can just tone it down a little bit. Also, I think, yeah, we can use numbers greater than 1. I don't know if that actually works. Maybe not. Let me try some other colors. This almost makes it look like there's only orange and nearly gray, but it does pick up everything that is visible. In terms of color, it's just well, whatever. Yeah, here is some stuff we can do with a Kinect. It's kind of cool that everything has the feedback applied to it, but let's try scaling this by depth norm again. Okay, that's not what I wanted. Maybe this kind of on-off logic again. Oh, it's 0, not 1. Yeah, this is cool because you kind of get those sharp outlines and then the glitch like happening within those instead of the blur, like constant blurring of everything that happens with feedback turned on everywhere. And then we can keep adjusting values to our liking. We can get really heavy with the displacement, distortion type of thing. To the point where this kind of stuff happens. What if I also scale the noise factors by depth norm? Does that do anything interesting? Yeah, it produces a bit more variation in the pattern, I guess. Not quite like that. Let me adjust this again. And then we can go into this totally glitchy territory. Now with the noise coordinates all scaled by the depth, we get some much more interesting patterns in the noise, I think. Yeah, I quite like this one. Although this way the color kind of gets lost completely. But let's try some smaller values. this is still kind of in the same territory, but with a bit more color. Now, what if we take basically this this vector, and we rotate it. I think there is a... Yep, there is a rotation function here. Yeah, that way we can get the displacement going in different directions. It's maybe a little too fast. But then this is maybe too slow. I don't know if I like the rotation that much. But if we actually just make it go really fast. Yeah, not really what I want. However, what if instead of time it was depth norm? And maybe even with a bit of a curve to it. Yeah, this is quite cool, I think, because now the direction kind of changes in 3D, in that if I come a little closer, then it's a different direction. I don't know if this is the right curve, but there's more we can do with this, such as take the sine of this. And a bit of a time variation to it. Ah, this is getting pretty good. Now the rotation could be maybe more. Yeah, I like this, and maybe. Yeah, this is becoming really cool. I think I'll join all my future Zoom calls like this. Yeah, it becomes quite mesmerizing at this point. um... Is the saturation effect good? I don't know. Let me try a different one. This is not right. I don't know. Yeah, I like this but I don't know, I feel like I kind of want to just maybe after this kind of resaturate. I don't know, does that make sense? Maybe this is pretty good after all. What else can I do with this? I'm thinking... I'm gonna try to still bring the hue shift in here somehow. See, now this is what I was thinking about. Yeah, we can get this kind of thing going, but... yeah, this is pretty good. I like the kind of shimmering, shifting color going on here. Let's bring Kirby in. Kirby is not really recognizable. What about this colorful turtle? By the way, it occurs to me that by adjusting the minimum saturation, this becomes more saturated in general, which makes sense, of course. Yeah, that is openFrameworks and Kinect and shaders and math and feedback and displacement and things of that nature. I think I might more or less wrap it up here. Maybe I'll tweak some parameters a bit further. It's kinda interesting to try this also with slower flow. Almost turns me into this like watercolory painted thing. We can go really slow. This is actually interesting because it lets us see properly how the hue shift changes depending on depth. So if I reduce this, then it did not really do what I expected. I would think it would become more gradual. Yeah, now it did. What if I now increase the flow again? Yeah, different results with different parameters. Ideally, I would make a lot of this stuff controllable via OSC for like live tweaking. But yes, that is gonna be tonight's stream. Thank you for tuning in. Just goes to show you can have a lot of fun with 1100 yen if you happen to be in the right place at the right time. I'm thinking of maybe I would like to use this as like a video or VJ thing while performing music, but the thing is, usually on stage there's not that much lighting, or you can get maybe a spotlight or something, but it might be that the Kinect has a hard time to see the RGB image is gonna be quite dark, because as you might notice, it is noticeably darker than my regular webcam here in the corner. But I'll have to experiment with that, and otherwise maybe it could be an installation thing. I said before that I've worked with Kinect previously, and that was in fact for an installation. Maybe as a final thing I could show you that if I can find a video. Maybe on Vimeo. Wait, can you logging in? Ugh. Yes, here we go. So yeah, this was an interactive music installation. So basically we have a Kinect tracking the 3D position of this orb that is part of this magic wand here, and that controls a machine learning synth, NSynth, one of the kind of early models. Well, it's from 3 years ago. The installation, the model is a little bit older than that. Yeah, I made the tracking code for this as well as the super collider code, which plays the composition. So let's just have a look. it's not the best recording. I guess it's done with like a camera mic instead of line out, but yeah. There's also a kind of a cool visualization that goes with this. Well, it's more like a developer view, but it's not visible here. Anyway, you get the idea. Yeah, I don't have any videos of the developer view, but that's fine. But yeah, you can do all sorts of fun installations with this kind of technology, and I would love to do more. Especially audio, visual, real-time stuff, interactive music and soundscapes and that kind of thing. And in fact, I will have some opportunities to do that in the future, next year specifically, so if you're in Finland, look forward to some more news on that. Otherwise, feel free to contact me if you would like to hire me to build cool audiovisual installations with interaction and whatnot. Okay, I'm getting super tired and I will wrap this up now. Thank you for tuning in. No music making tonight. I think it's fun to do some visual stuff for a change, and I will think about ways to use the Kinect data for also audio stuff. Like what Microsoft actually did with the Kinect in the games, I think was like skeleton tracking mostly. I don't think the Kinect maybe does anything like that in the hardware itself, so probably that relied on their SDK, which we don't have access to when using Kinect. Let me just look up if there's something like that in Kinect. It might be that you just have to plug in OpenCV. Okay, there is something. Right, well, yeah, it's something to look into. If you happen to know any good libraries that you have experience with for skeleton tracking, specifically with Kinect, ideally taking advantage of the depth camera, then let me know in the comments or something like that, or via any of my contact methods, which you can find here on my website pulusound.fi. Yeah, that's gonna be it. Thank you once more for tuning in. More streams in the future. I actually now have the mini DVI to... no, sorry, mini VGA to VGA adapter, and then a VGA to HDMI converter, which I need for getting video out from the iBook. So at some point I'm gonna do more of that iBook stuff, so retro super glider and building a early 2000s style super glider live setup. If you missed those streams, you can go check them out on my YouTube channel, so you know what that is about. Alright. That's it. Like, follow, subscribe, leave a comment. Click on all the buttons to make the numbers go up. Yeah. Thank you. Good night.